Okay, guys and gals, welcome to our second video lesson in Chapter 4, our lesson that continues with the unit circle and trigonometric functions. Here we go. Okay, first of all, you need to write these down into your notes. So stop the tape and take a minute. Write these 6 reciprocal identities down into your notes and the 2 quotient identities. Go ahead and give it a go. Okay, now that you have those first 8 identities written down, there are 3 more important ones called the Pythagorean identities that we're going to talk about right now. You know that on the unit circle, if this angle right here is my theta, okay, this is a right triangle. I'm going to call, this ordered pair right here is x comma y. Right? We know that this length right here is x. This length right here is y. This length right here is the radius, which is also 1. So we know that x squared plus y squared is equal to 1 squared. 1 squared, which means x squared plus y squared is also equal to 1. And we know that because that is the square root of 1 is 1. Okay? Now, we also know that x, of course, is sine. X, of course, is cosine. And y, of course, is sine. So, therefore, on the unit circle, cosine squared plus sine squared is equal to 1. And that is our most important, our basic Pythagorean identity. You could do some algebra if you wanted to, and also you could rewrite both of these things, or this as cosine squared is equal to 1 minus sine squared by subtracting sine from both sides. Or I could also subtract cosine squared from both sides and get sine squared is equal to 1 minus cos squared. So we basically have, in this red box here, we have 3 Pythagorean identities, which all say the same thing. Cosine squared plus sine squared is equal to 1. For those of you who are mesmerizers, you may want to memorize, or at least familiarize with those other 2 as well. We're going to use this cosine squared plus sine squared is equal to 1, and we are going to quickly take this equation. We're going to divide each of these terms by cosine squared. When I do that, you will notice that cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared we know is tan squared. And 1 over cosine squared is the reciprocal of cosine squared, which we just found out is secant squared. Now we have our second important Pythagorean identity. 1 plus tan squared is equal to secant squared. If I wanted to, I could subtract tan squared and write that also as 1 is equal to secant squared minus tan squared. Or I could subtract the 1 from both sides and get tan squared is equal to secant squared minus 1. So again, in this green box right here, we have our second 3 Pythagorean identities, which all say the same thing. And lastly, I'll do this real quick because it's the same idea. I can take my original equation, cosine squared plus sine squared is equal to 1. And I'm going to switch colors here and get something new. Let's try this bluish thing. I'm going to divide each of these not by cosine squared this time, but by sine squared. When I do that, I get cosine squared divided by sine squared is cotan squared. Sine squared divided by sine squared is 1. And 1 divided by sine squared is the reciprocal of sine squared, which is cosecant squared. Once again, I can rewrite each of these equations as not only cotan squared plus 1, but I can do 1 is equal to cosecant squared minus cotan squared, or I can do cotan squared is equal to cosecant squared minus 1. Okay, there are your identities. Okay, let's do a few homework examples. I have a poem for you. It goes like this. When in doubt, draw a triangle. Okay, so we're going to look at exercise 13 here. It says, in exercise 13 through 20, sketch a right triangle according to the trigonometric function of the acute angle theta. So it's an acute angle each time, which means it must be in the first quadrant. Use the Pythagorean theorem to determine the third side of the triangle, and then five other trigonometric functions. So, in this particular case, in number 13, we have sine theta is equal to 5 over 6. So here is my theta. My sine is my opposite, 5, over the hypotenuse is 6. So using the Pythagorean triple real quick, my adjacent side, I know that a squared plus 5 squared is equal to 6 squared. I was getting ahead of myself. Right at 36. 6 squared. So I know that a squared plus 25 is equal to 36. Real quick, a squared is equal to 11, which means that this adjacent side must be root 11. Now that I have that, I can find all my remaining pieces. I know that my sine was 5 over 6. I know my cosine is going to be opposite over the hypotenuse, which is root 11 over 6. I know that my tangent is going to be opposite over adjacent, which is 5 over root 11. Technically speaking, we should rationalize that. So we're going to multiply by root 11 over root 11, which equals now 5 root 11 over 11. Okay? To get the reciprocal functions, the reciprocal of sine is cosecant. So that's going to be 6 over 5. The reciprocal of cosine is secant. That's going to be 6 over root 11, which again, if I rationalize, I'm going to get 6 root 11 over 11. And the reciprocal of tan, I could take the reciprocal of that if I wanted to, but it might be easier just to go right to here and take the reciprocal of that. So the reciprocal of tan is cotan, which equals now, it looks like root 11 over 5. Okay, so looking at problem number 23, we are going to, first of all, draw a triangle. When in doubt, draw the triangle. We are going to use our 36, 60, 90 right triangles, and we'll just do tangent here. We can probably do all these real quick. But looking at this tangent, I know that my theta, okay, is equal to pi over 3. I just kind of know that that's 60 degrees, because 180 divided by 3 is 60. Now, looking at this picture, my 36, 60, 90 right triangle, my theta is 60, which means this is going to be 30, and here is my right angle. So now using my special rights, the hypotenuse is 2, side opposite the 30 is 1, and the side opposite the 60 is root 3. So the tangent of 60 is going to be the opposite over the adjacent, which is root 3 over 1. If we just look here, we could also find sine of 30 if we wanted to. Okay, the sine 30 in radians is pi over 6. Okay, but the sine of 30 right here would be the opposite 1 over the hypotenuse, which is 2, so that's 1/2. Okay, and cosine of 60 would be 1 over 2. All right, why don't you guys? All right, we'll do one more together here. Again, when in doubt, draw the triangle. I'm looking here. I don't know what quadrant I'm in until I look. But in this particular case, number 55, the cosecant of theta is 3, which is positive, and the secant is also positive. Therefore, I know I'm in the first quadrant. Sure enough, now my theta is a first quadrant angle. I know my cosecant is 3, which means the sine is 1/3. So I'm going to do that right now, and I have 1/3. I couldn't look here, but that's a pretty yucky number to work with. So I'm just going to use the Pythagorean theorem right now to figure out my missing side. I know that 1 squared plus my missing side squared is equal to 3 squared. So 1 plus x squared is equal to 9. X squared is equal to 8. So x is equal to root 8, which of course is 2 root 2. So now that we have that, we can figure out all of these answers. Sine theta is going to be opposite 1 over the hypotenuse 3, 1/3. Cosine theta is going to be the adjacent over the hypotenuse, which is 2 root 2 over 3. Tan theta is going to be 1 over 2 root 2, which of course now I need to rationalize. It looks like I have root 2 over 2 times root 2 times root 2 is 4. And finally, the secant of this thing, this says the complement of theta. 90 minus theta is going to be the complement of theta, which is this angle right here. So the secant of that is going to be the reciprocal of cosine. So the cosine of this angle is 1/3, 1/3. So the reciprocal of 1/3 is 3. All right, I think we got one last problem here, or maybe two. Find y and r in this picture. I know that sine of 30 is equal to opposite, which is y, over r. So far, I don't have much to go on. However, I do know also that cosine of 30 is equal to 105, the adjacent, over the hypotenuse, which is r. I should be able to solve this for r now. Cosine 30 is just a number. You can whip out your calculators, or we can work with radicals if you would prefer. But we're going to multiply both sides of my equation by r. So I have r cosine 30 is equal to 105. Okay? Whip out your calcs. Cosine of 30 is root 3 over 2. So we're going to divide both sides by cosine of 30. So whip out your calcs and do 105 divided by cosine 30. Okay, you should have gotten r is 121 point, hold on, let me grab my calcs, I just did it. 121.24. Okay, now that we have r is 121.24, we can figure out y by going back up to here. And I know that sine 30, so sine of 30 is equal to y over r. Well, I know that r was 121.24. Sine of 30 is 1/2. So y is equal to sine of 30, which is 1/2, times r, which was 121.24. And that answer is 60.621.